Hello, everyone. Thank you for waiting. It takes a bit extra minute to get it started. So I just jump into it because we only have 15 minutes here. So my presentation today, the topic is about catching hacker among 70 billion events. And since it's a developer forum, what I'm going to focus on is how to build a scalable distributed system in order to do intrusion detection. So a few words about who I am. I have been some years as a developer, and I joined this company called Mnemonic, which is located in Norway, Oslo, which is a security company. And in the last few years, I had been establishing and growing the development team focused on the distributed team part. And this distributed team is responsible for the real-time incident detection platform. We're going to talk a little bit about in this presentation. What is real-time incident detection now? And about Mnemonic is one of the leader in Europe in cybersecurity field, and is a true player in the cybersecurity. And this year is actually 25th anniversary. It's really lucky to be here. So before I jump into technical details, let me take you to a quick journey to the neon streets of Cyberpunk 2077, if you have played the game. So in this world, there's a lot of hackers trying to hack into your system, trying to grab your valuable assets. And the hacker may connect to your domain controller and try different kind of passwords, trying to crack it. And even the hacker may have really advanced cracking tools. So what you need is some expert that's able to help you detect and defend against such a hacker. And in real life, our job is not like that. It's more like this. So this is our SOC center, Security Operational Center, that runs 24/7. So we have dedicated security specialists sitting there and monitoring. Or when the incidents come in from the customer network, they get monitored, they get alerted, and they start analyzing the incidents and report to the customer or do other kind of action. And today, what I'm going to talk about is the detection pipeline. And this pipeline has a few key numbers. And the following chart shows during one random day, the whole ecosystem of pipeline is having 72 billion raw inputs ingested. This is from different data sources. I'm going to mention about that. And then among those 72 billion, 39 million incidents actually getting detected. And only around, press too quick. Anyway, it doesn't let me to show. Maybe it's secret. So now it shows. So over 2,000 actually sent to the SOC to get human analyzed. But that does not mean we drop all the rest of 39 million. Those events are used by automatically processing, automatic detection, and also by reporting purposes. So all of those events are getting used. And regarding the raw event inputs, we did some measuring over the years. And this chart shows the trend of increasing of the amount of raw events received. From statistic in 2022, we're getting around 29 billion events in the overall ecosystem. And then in the 2023, it's nearly doubled. It's to 56. And 2024, it's increased another like 30-40% again. So this year, we didn't get yearly measurements yet, and I think it's still continuing increasing. So if you are a developer trying to develop such a system to be able to handle this amount of potential raw events, there are a few challenges, at least we are facing. The first one is regarding scalability and performance. In order to process these 70 billion events and also increasing and growing, this is one big issue. And due to the data that gets in can be different formats, and new formats keep getting introduced. So your system needs to be flexible to adapt to new formats as well. And of course, and also for the detection, in order to help customer, we need to have near real-time analysis. So the pipeline cannot take too long to process the event. And next, about detection accuracy and efficiency. And for the SOC analyst, we are human. We have limited capacity. So the goal for the pipeline is to be able to reduce the amount of false positive. in order to provide actual incidents that needs to be analyzed. So in order to build the trust also into the detection we have. And then, very importantly, is to be able to provide rich context about why this incident is detected as an incident. What's the reason? Is it because the IP has a really bad reputation in the past time? Or is it because the user logging into different location within a minute, have an impossible travel? So this is a bit of challenge when it comes to using AI to this field, is to give the explanation in that. But we are also trying to explore into that. And lastly, the hackers are keep learning new things, then they are having new techniques, new tools. So the solution intrusion detection platform needs to be quickly adapted to the new threats, new techniques. And these are the challenges. But today, with a limited time, I'm gonna spend some time onto this scalability part and how we design our solution to be scalable. So in the bottom line is to divide and conquer in order to handle such a big data problem. And nowadays it's called edge computing, but this system has been built since more than 20 years ago. So at that time, we are already developing the system, and that's getting deployed to globally, to customer data center, to our own data center, and some part in the cloud nowadays. So we try to get the server close to the data source, where the customer data center located. And in the real management portal we have, as you can see, there are multiple rows here I'm presenting. Each row is one virtual server or physical bare metal server somewhere in the world. And it contains different components over here. And these components you can think as Lego pieces. Each green boxes on the bottom right side, they have different functionality. Some are for ingestion from source data, some are doing transformations, some are generating metrics. And you can customize your pipeline depending on the customer needs and to using different components into that. And to dive a bit deeper into what usually a pipeline looks like, now on this side, we have different kind of data sources. It came from IDS solution like Suricata, it came from cloud, it came from other firewall things, but you ingest using solution like Logstash. And it came from the CM solution like Splunk, different kind of data sources. And then we introduce different types of agents. For some dedicated vendor, we have dedicated solution to integrate with the vendor, such as Suricata and Splunk agents. And also, we also define our vendor agnostic agent in order to define data formats. So any kind of inputs is following that data format, we are able to get ingested into the pipeline. And the reason to have this part of integration is to be able to, first, to be compatible with the input data formats, and then transform to our own data formats to prepare it for the later processing. And then all those events that's getting ingested through the agent are sent into the analyzer component. This is our brain of the detection. There are hundreds of rules developed by in-house security specialists that we provide our platform to help executing those hundreds of rules in real time to be able to detect incidents. And then, even after the rule detection, there can be still too many events that's getting generated. In order to further reduce the workload towards the SOC analyst, we have aggregation phase. In this phase, events look similar. For example, they're from the same source network. They may aggregate it together. And lastly, they are getting uploaded through REST API to our central backend and presented to the user and for reporting purposes. And for the scaling part, for developer, you may already see in this pipeline there are many components, and any part of the component may face the bottleneck when it comes to higher throughputs. So in this case, for example, this one is about agent. If the Suricata is generating a lot of events, increasingly amount of events over time, we use Kafka as a middleware. So as you may know, the Kafka is able to partition the data to different partitions. And then depends on the amount of partitions, we have multiple consumer. And each consumer could run on different hardware. So in that way, you're able to split the traffic through different hardware. You get horizontal scalability for the input part. For the processing part, we're still using Kafka, but there is a little bit more challenge because for processing, sometimes we have correlation processing needed. And for correlation processing, we need some states to be shared. And in order to do that, we use Hazelcast in this case. And the states are getting shared through the Hazelcast to different nodes in the cluster. And this way allows us to scale the processing part as well. And I guess someone may have saw this image and may get unlucky last summer, as I was, and getting stuck in the airport. So in order to, when working with distributed system, when we have to handle so many different kind of data and so many servers involved, so we are really careful doing the QA part. And for deployment part especially, since we have 100 servers globally, so we group them to different stages. And we deploy to stage 1, which is lowest risk, and gradually deploy to other places. It might take more time, but it certainly reduces a lot of risk when we're pushing out new changes. And also continuously monitoring and alerting is essentially important. The pipeline is running in different hardware environments. Some could be OT environments, which have really limited hardware resources. And you really need to carefully understand what is the issue causing the component stop. Is it because the network bandwidth exhaustion? Or is it because the memory, the GC, is running out of memory? There's so many reasons could cause the component to fail. And as you may have heard about from Holly's presentation earlier today in this room, the concurrency is really difficult. And we share the same pain over there. And also with distributed system and with the amount of data and variety of data we're handling, it doesn't make it any easier. What we take as a strategy is we want to do fail fast and fail early. This is not like startup slogan over here. So what we mean is we don't trust any input we are getting. We always validate any kind of input. And also the exceptions, maybe in many applications, you just don't care about. It's a runtime exception, okay, let it go. But for us, it's really important to understand what's the cause of exception. And we need to define different tactics to handle different exceptions, since we cannot lose any single event, which can be hacker attacking the system, and we cannot afford to lose that event. And validate assumption. This one we learned through experience or through pain. When developing, there is a lot of assumptions involved. And we always found, I think, best explains by Murphy's Law, anything that can go wrong will go wrong. And we certainly learned that in the hard way. And unfortunately, there's always a new way that we can fail. So, for example, in one time when we deploy a code, there is just one line of change, but then that causing 90% of performance drop. And in that situation, we scratch our heads, what can go wrong? It's just one line of code change. But turns out it's causing every single event. And here we are talking about 70 billion events, trying to query against local database. That certainly slows down a lot. It somehow managed to go through the PR cycle, and we managed to catch it in the QA session during the staging environment. So we get lucky at that time. And most importantly, you need to be really flexible and keep learning. If you think you know it all, there's always a new way to hit you. And lastly, I'd like to share one of my favorite games recently, the Black Myth Wukong. So it's like playing this kind of soul-like game. In the beginning, when I joined the distributed system team, I found it so difficult. So many concurrency issues. It's so hard to understand about this incident, why this could happen, why the Linux doesn't work for that. But over time, after practicing, after keep learning, I'm getting better. And you get a sense of achievements through this period. So that's the presentation from me. Thank you so much.